Hi, I'm Shunichi Koshimura. I'd like to share with you our research and practices on TsunamiCast by real-time impact-based tsunami-focused facility. This is no longer a research project, but fully operational by東北 University-based startup RTICast, the unique private-based tsunami-focused provider. What we do is based on experience and the lessons we had in the catastrophe in 2011 that caused more than 18,000 fatalities, up to about 3% of the population in the inundation zone. We experienced severe impact by the tsunami inland penetration. So many activities would be fall behind in the first response, disaster relief, and recovery because of the lack of the information of the tsunami impact. Having the lessons, what we are really concerned about is the tsunami information for resilience. First, let me show the standard tsunami warning messages provided by tsunami warning organizations. I think this is a quite general kind of information. We have major tsunami warning, and tsunami advisory based on the rapid estimation of coastal tsunami height with pre-computed tsunami propagation model database. Again, these messages are based on the rapid estimation of coastal tsunami height. My point is there is no inundation-focused information provided. That is what we are doing. What we do, TsunamiCast in Japan is a fully operational GNSS-based tsunami inundation forecast by running Tohoku University's tsunami simulation code with supercomputing capability. Take a look at the right-hand side. We are using the GNSS data of the coastal movement to determine the forward rupture model. Then we are using that forward rupture model as a tsunami source to run the tsunami propagation and inundation simulation. That is on the left to acquire the estimation of tsunami inundation. We are doing this in real time with a supercomputer in Tohoku University. This is TsunamiCast in Japan. The value of TsunamiCast with full capability of the real-time tsunami inundation focused facility is supporting disaster resilience. That means to reduce losses and recover quickly. TsunamiCast provides information on how extensively the tsunami penetrates inland. In other words, where is a safe place? How many people are exposed? And how many structures or infrastructures are damaged? How extensive disaster relief activities should be deployed? And how much losses are? I think all of you will agree with this. Those are very critical information for the first responders in the aftermath of the tsunami event occurs. Now, our system is almost fully nationwide in Japan. Our main customers are the Cabinet Office of Japan, the central government, and prefectural governments. We started TsunamiCast in 2018, then have been expanding our forecasting area. Let me show you how fast this simulation is. I'm showing here the performance of TsunamiCast for diverse users using the multi-platforms of the high-performance computing infrastructure. The inundation model is based on the nonlinear shallow water theory with 10-meter grid resolution. These bars are showing the time to complete the forecast for next 6 hours within 10-meter grid resolution. Our supercomputer has the performance to complete the simulation within a couple of minutes, and also using the GPU clusters of NVIDIA show the same performance that achieve finishing the computation within 4 to 6 minutes. This means that TsunamiCast capability can be expanded to GPU computing platforms in both the cloud system and on-premises server. This makes it possible to transfer TsunamiCast to the world. Now, let me show you some TsunamiCast products. This is tsunami arrival time for inland penetration. I think this product is critical for evacuation planning to show which part of the land will be inundated in the expected time of arrival. Next is the inundation depth, with the extent of inundation, and the users can add their own information or data. This is an example to add critical facilities of vertical evacuation shelters for the prefectural government users. They are concerned about how each of the vertical evacuation facilities will be inundated, how many people are in these buildings. Then, we apply the tsunami fragility curve to quantitatively estimate the structural damage and also expose the population. Those are standard TsunamiCast product. Ultimately, our goal is to realize TsunamiCast as a life-saving service that provides personalized alerts by incorporating real-time individual location data into the system. This enables the delivery of the tailored guidance to support survival and enhance individual resilience during tsunami events. A key challenge lies in acquiring the capability to sense real-world human activities while addressing privacy concerns. Nevertheless, overcoming this challenge represents one of our innovation objectives. Now, how we expand TsunamiCast capability towards the global real-time impact-based tsunami-focused facility. There are three functionalities to be integrated. The first is the rapid determination of tsunami source model. This can be made through the collaboration with the seismic monitoring organizations in the user countries. We propose two kinds of urgent computing platforms of cloud computing system and on-premises servers having the GPU computing capabilities. The last one is the web-based mapping so that the users get an easy access to the mapping products. Through expanding TsunamiCast to the world, we aim to contribute to achieving the UN global agendas of tsunami ready and early warnings for all. Working with the partners to prepare high-resolution bathymetry and topography data, we are providing the focused products. For tsunami ready, producing the tsunami hazard assessment, tsunami evacuation plan, and emergency response plan. For the early warnings, we are going to produce the tsunami inundation focused products, supporting dissemination and communication of the warning messages and emergency response. We propose the real-time impact-based tsunami inundation focused facility. This is a cost-effective solution for promoting cooperation to develop new products and services to accelerate early warnings for all and tsunami ready, emphasizing the importance of endorsing private sectors to accelerate the efforts. Besides, we believe that this can contribute to the Sendai framework's priorities for action, especially on investing in disaster risk reduction for resilience to fill the gap between the science and practice of tsunami inundation focus. Thank you for your kind attention. Please visit TsunamiCast channel on YouTube.